Okay, so what we're going to do here is we are taking a look at how do we determine the domain and range of a function provided by a graph. And a lot of times this is a little challenging because we have to imagine what's physically going on. And when you're focusing on the domain, you're interested in what's taking place with the x values. And you see how I added, right? The domain is the set of all possible input values of a function, where the range is the set of all possible output values of a function. So one is referring to the x-axis, one is referring to the y-axis. And what you're interested here is you're thinking about the thousands of ordered pairs on your graph. What can these values of x be? And that trickles down to, if this is going here, then this would be this x value, this would be this x value, this would be this x value, all the way when you get here, this here would be this x value. So from here to here, the values of x that you could think about would be there. So sometimes it's not just the ones we see, but the ones that we imagine. And if we're dealing with the range, now we're taking this point, and this now trickles to the y-axis. So all of these ordered pairs, what are the y coordinates, okay, of that? So let's take a look here at a couple of examples. We're not going to take a look at too many, but let's take a look at a few, and this is still in section 3.2. So let's take a look here at problem number 30. And problem number 30, is asking for the domain and range. The domain and range. So when I'm asking myself at this ordered pair here and this ordered pair, let's see what's going on here. You have to say that this ordered pair would be 2, negative. So 2, negative 2. And this ordered pair looks like it's going to be 6, negative 2. And then you have all the points that are in between. So when I take a look at this and I'm asking myself what would be the domain, well, the domain is, well, what values of x can you be? That's the visual. So if you drop up to this x-axis, you know the smallest value is 2. If you drop this one up to the x-axis, it's 2 point something. Then maybe here, this will go up to 3. And then here, you could go to 3 point something. And then here, you could go to 4. And then here, you could go to 4 point something. So the smallest value is 2. But if you come here, then the largest value would be 6. So then we will have 2 to 6. And notice that they're included, right? Whereas the range, well, what would you think about the range? Let's think about that. So the range, so if you kind of clear up this mess here, now you're going to the y-axis. So the y-axis here is a negative 2. The y-axis here is a negative 2 point something. And then here it's negative 4. Here it is negative 6. But then when you get back over here, it goes to negative 4. And then when you get back over here, it's negative 2. And remember, when you're writing interval notation, you always write the smallest value first. So the smallest value, it appears to be a negative 6. Anything between that and a negative 2. And that again is because if you close this up, then you have these closed circles. And it varies. Different graphs are going to have different domain and ranges. And if you take a look here at problem number 33, now look at this point. What is that ordered pair? Well, that ordered pair is 1, 0. And now you're interested what value of x is on that point, that point, that point, that point, that point, that point, that point. Since there's an arrow, it says that these points will continue on forever. Forever, ever? Yes, forever, ever. And that is going down to negative infinity. So what this is illustrating here is that the domain is, and what we'll have is negative infinity to 1 with a bracket. However, the range is going to be different. And the reason why is because what is this ordered pair? Well, the smallest value that y takes is 0. But these points, if you trace back to the y-axis, those y values will be getting larger and larger and larger. So in this case, you would have a bracket 0 to positive infinity. And that's why it's so important to understand the difference between when you use brackets opposed to when you use infinity. And so in this particular case, why don't you give number 31 a try?